Pluto's circle crosses that of a few other planets. Pluto, the hard little planet on the outside scopes of our close-by planetary organization, is working up electricity on Earth. Ongoing reviews suggest a plausible issue with Neptune, raising issues among researchers and space enthusiasts. Key figures like Neil deGrasse Tyson and Michio Kaku have sounded cautions about the ramifications of this infinite occasion. However, how did Pluto develop to become on a crash path with its adjacent planet, and what should this heavenly conflict propose for life on Earth? Be a part of us as we disentangle how something huge simply slammed into Neptune and how researchers have been left burdened by this enormous irregularity. Pluto, once hailed as a planet, went through a change in its reputation, being renamed as a dwarf planet due to its unconventional orbit. Notwithstanding this downgrade, Pluto sincerely spellbinds and pursues the cosmic nearby region. Later forecasts from esteemed researchers like Neil deGrasse Tyson and Michio Kaku have raised issues about Pluto's route likely converging with Neptune, indicating an approaching string of outcomes between the two divine bodies that could have crucial repercussions for Earth. Pluto's excursion around the Sun stands apart due to its pinnacle-notch attributes inside our nearby solar system. Its orbit is primarily tremendous, crossing a beautiful amount of astronomical units. Considering its revelation in 1930, Pluto has yet to finish a full orbit around the Sun. Adding to its character is the profoundly stretched nature of its orbit, a departure from the more roundabout approaches followed by the big planets. Furthermore, Pluto's orbit strays by 17 degrees from the ecliptic plane, giving its path a more intense grade compared to one of the major planets. The combination of Pluto's nature and its curved orbit provides layers of intricacy to its trajectory. One prominent aspect is its occasional convergence with Neptune's orbit. For about 20 years throughout each orbit, Pluto ventures closer to the Sun than Neptune, resisting assumptions based on their separate positions within the nearby planetary system. Digging further into Pluto's orbit, it is captivating to notice that it is not an extraordinary circle but rather an elongated one, reminiscent of an oval shape. This notable orbit results in vital variations in Pluto's distance from the Sun throughout its tour. At its closest approach, Pluto comes within about 30 astronomical units of the Sun, while at its farthest point, it reaches more than 49 times the distance of Neptune from the Sun. Further, Pluto's orbit is tilted at an angle relative to the orbits of the major planets in our nearby solar system. This inclination not only adds to the complexity of its orbit but also plays a crucial role in its interactions with specific celestial bodies, especially Neptune. When Pluto encounters Neptune, their gravitational influences adjust their directions over time. The many-sided dance between Pluto and Neptune highlights the dynamic nature of our nearby planetary group. Even as Pluto was once considered a solitary drifter in the outer reaches, its nearby encounters with Neptune spotlight the interconnectedness of celestial bodies, each utilizing gravitational forces that shape the paths of others. In later years, advancements in observational technology have assisted cosmologists in tuning Pluto's actions with remarkable accuracy. This has led to a deeper understanding of its orbit and its potential ramifications for the stability of the outer solar system. Even as the chance of a direct impact between Pluto and Neptune remains low, the possibility cannot be completely discounted, prompting continued tracking and testing by the astronomical community. Despite its modest size and distance, Pluto continues to command interest and intrigue among researchers and enthusiasts alike. The question arises, why hasn't there been a collision between Pluto and Neptune? The answer lies within the pull of gravity from major planets. Astronomers began focusing on Pluto's path not long after discovering it, and its orbit baffled them. Unlike most planets that stick close to similar planes as they orbit the Sun, known as the ecliptic plane, Pluto stands out with its tilted and oval-shaped orbit. The mystery deepens when considering that Pluto's path crosses Neptune's. Despite these intricacies, Pluto's orbit remains stable, showcasing the complex mechanics of space. Understanding how three celestial bodies interact gravitationally, like Pluto, Neptune, and the Sun, is a significant challenge. It's akin to predicting where they will go based solely on where they start and how they influence each other. For Pluto, this venture illustrates how its path, Neptune's path, and the Sun's influence interact in a complex simulation of libration and the VSOP variations. These factors help researchers settle the significant riddle of Pluto's orbit. A simulation is crucial for maintaining planets in their orbits. While Pluto crosses Neptune's path, it is at least 90 degrees away, preventing a collision. Libration ensures that even as Pluto approaches Neptune or other large planets, it remains well clear of their path, reducing the risk of a crash. The VSOP variations, named after researchers, explain why Pluto's orbit appears eccentric but remains stable over the long term. Despite the chaos in space, certain patterns and rules keep things in order. These guidelines maintain Pluto's orbit stable, preventing collisions with Neptune or changes in its path. The possibility of orbital mayhem demonstrates how a celestial body's trajectory is highly sensitive to its starting position, as illustrated by Pluto. Even minor changes in its position or velocity can drastically alter its orbit over time. Researchers use computer simulations to understand how Pluto interacts with other celestial objects like Neptune. By tweaking these simulations, they can grasp how small modifications can impact Pluto's path in the long run. In the late 1990s, these simulations uncovered intriguing aspects of Pluto's orbit. Despite issues that might destabilize it, Pluto's orbit remains remarkably stable over billions of years. This indicates that although Pluto's path may seem chaotic, its journey across the solar system follows a consistent pattern. Looking ahead at what might happen with planets like Pluto that have irregular orbits is challenging. These systems are so unpredictable that it's difficult to foresee what will occur over the long term. Simulations help us understand potential outcomes, but also show us that we cannot predict everything. This knowledge helps us better understand how our solar system works. Pluto's orbit illustrates how seemingly erratic orbits can be influenced by gravity and how objects move in space. Continuing to study these phenomena is essential as it helps us comprehend our place in the universe. When examining space, we realize that objects can be unpredictable, and Pluto's orbit is a prime example of this volatility. Pluto's orbit differs from those of other planets. It is more oval-shaped, meaning it is not a perfect circle. At times, it even comes closer to the Sun than Neptune does. This adds excitement because Neptune is also moving along its orbit. There is a small chance that Pluto and Neptune may come close to each other sooner or later. Despite its unusual orbit, Pluto manages to avoid Neptune most of the time thanks to gravitational forces. Gravity acts as an invisible force that pulls objects toward each other. Even though Pluto and Neptune might seem to be on a collision course, their orbits are carefully arranged due to the pull of gravity. Pluto's orbit teaches us that space is full of surprises. What initially seems chaotic can be a delicate balance of forces. By studying Pluto's orbit, researchers gain insights into the complex mechanics of our solar system. This ongoing observation and research are vital for expanding our knowledge of the universe and our place in it. If Pluto and Neptune were to collide, it would be a significant event, sending shockwaves through our understanding of the solar system. While we have made progress in studying space, much remains unknown. Understanding the dynamics of Pluto's orbit provides valuable insights into how our entire planetary system functions. It shows us how the positions and movements of planets can affect the trajectories of other celestial objects. Despite the complexity of space, some researchers are concerned that Pluto could collide with Neptune. This raises questions about why such an event might occur, even though it seems unlikely. Neil deGrasse Tyson, a renowned space scientist, has expressed interest in Pluto. He believes that renaming Pluto as a dwarf planet rather than a major one like Earth is a step forward. He feels we are continually learning new things about how objects move in space. Tyson views Pluto's unusual orbit as a sign that there is still much we don't understand. He finds the mysteries of space captivating and recognizes that significant events like Pluto's renaming engage people in space science. Tyson hopes to help people stay interested in the intriguing and sometimes peculiar aspects of space. He believes it is important to discuss how celestial mechanics work. Tyson collaborates with other researchers to warn people about the potential risks of Pluto's unusual orbit. He focuses on the possibility of a future collision between Pluto and Neptune and how it could impact our entire planetary system. A collision between Pluto and Neptune would be an unusual and significant event. It could release a tremendous amount of energy and potentially break Pluto into pieces. Debris from the collision could scatter through space, hitting other planets and moons. Neptune might also experience the impact, altering its trajectory. Renowned theoretical physicist Michio Kaku, known for his contributions to string theory and technology, has shared an intriguing perspective on space exploration. He believes that understanding the future of space travel and the relationship between celestial mechanics and theoretical physics can be achieved by examining anomalies like Pluto's orbit. Kaku considers Pluto's orbit to be a window into the future of space exploration. By understanding the complex gravitational interactions and orbital dynamics of celestial bodies like Pluto, we can improve future space missions, helping with safer navigation through the solar system. Predicting potential dangers and planning missions to parts of our cosmic neighborhood is crucial. Kaku emphasizes that lessons learned from Pluto's orbit can be applied to exploring other celestial bodies, providing a roadmap for exploring distant worlds. He often highlights the deep connection between celestial mechanics and theoretical physics, stressing that the interactions of planets, including the gravitational dance between Pluto and Neptune, are rooted in fundamental concepts of physics. Kaku's work in theoretical physics has led him to delve into these intricate cosmic phenomena. He suggests that comprehending these interactions is vital for space exploration. Ultimately, understanding the orbital dynamics of celestial bodies like Pluto offers us an opportunity to enhance our knowledge of the universe. It enables us to navigate the cosmos and plan space missions that unlock the secrets of distant worlds.